All right, let's talk about something that trips up almost everyone working with AI. It's this idea of consistency. You put something in, you expect the same thing out every single time. Today, we're going to dig into why that's not how AI works and what that means for building safe systems. Think about it. With most software you use, this is a given, right? If you type the same words into a search bar or run the same command, you expect the same result. It's how we're trained to think. You find a prompt that works perfectly, so you expect it to work perfectly again tomorrow. But here's the thing. In the world of AI, holding on to that assumption is actually a huge risk. When an AI gives you a different answer to the same question, it's not broken. It's not a bug. It's a fundamental misunderstanding of what these systems actually are and how they operate. To really get our heads around this, we need to break down two key concepts that are at the heart of AI behavior: variance and drift. And let me be clear, these aren't problems to be solved. They're properties to be managed. Okay, first up is variance. This is basically the reason you get slightly different outputs, even when you use the exact same prompt. And that last part on the slide is absolutely crucial. This isn't a malfunction. AI systems are probabilistic. They're built on complex math and sampling. That means a range of possible answers isn't just possible, it's the expected behavior. It's a feature, not a bug. So you might be wondering, well, if this is so normal, why does it always catch us off guard? It's because when you first start playing with an AI, the results usually seem pretty consistent. This creates this false sense of security. You start to trust it, you build things on top of it, and that's when the weird, less common outputs start to show up. Variance has this sneaky way of waiting until your guard is down. And that brings us to our second big idea: drift. So if variance is about the little differences from one moment to the next, drift is a much slower, more gradual change. We're talking about the system's overall behavior changing over weeks or even months, all without a single line of your code being touched. So where does this drift come from? Well, it can be a bunch of things. Maybe the developers pushed a silent update to the underlying model, or maybe the kind of data the model is seeing out in the world has changed. It could even be that the way users are interacting with it is slowly teaching it new patterns. It's this quiet background evolution. And this is where it gets really dangerous. Drift completely undermines the trust you have in a system. All the guardrails and processes you built based on how the AI worked a month ago, they might be useless now. Failures can start to creep in silently because you're assuming a level of stability that just isn't there anymore. Okay, so we've got these two concepts down: variance and drift. Now let's look at why they become such a massive deal in real-world applications. And to do that, we're going to use this really helpful framework called the lifecycle lens. Okay, so take a look at this diagram. The whole point of the lifecycle lens is to map out AI use cases based on how much power or authority we give them. You can see it moves from left to right, from P1 to P7. Over on the far left, the AI is just an assistant. It's giving you ideas. But as you move to the right, its authority grows until it's actually operational. It's taking actions on its own. This shows perfectly that the risk isn't about the model itself. It's about the job we give it to do. Let's start on the left side of this thing in what we call the assistive AI zone. In these early stages, maybe the AI is helping you brainstorm or summarizing a document. If the output varies a little bit, no big deal. It's an inconvenience, sure, but you can just ask again or ignore it. The stakes are super low because the system is basically read-only. But then we hit this critical line right in the middle, the authority boundary. This is the moment an AI stops just giving you suggestions and starts becoming part of an automated system. The second we cross this line, the entire risk calculation changes, like fundamentally. Because once you're on the right side in operational AI, the system can actually do things. It can create a support ticket. It can replan an entire project schedule. It can execute code. Now think about that same little bit of variance we talked about earlier. It's not an inconvenience anymore. It's a potential disaster. A slightly different output could trigger the wrong action with real, sometimes irreversible consequences. So what do we do? If variance and drift are just baked into these systems and the risk gets bigger and bigger as we give them more authority, how do we ever build anything safely? Well, the key is to stop trying to fight these properties and start designing for them. So let's talk about what not to do. The most common mistake is treating variance like it's a bug that you can just squash. You see teams pile on more and more constraints, trying to force the AI to be perfectly predictable. But that's like trying to tell the ocean not to have waves. It's just not going to work. And you absolutely cannot rely on a single successful test. That's just an anecdote, not evidence. So instead, We have to completely change our approach. First, you have to evaluate your system across hundreds, maybe thousands of repeated runs to see the full range of its behavior. You have to collect evidence over time, not just from a few cherry-picked examples. That means you need to build in monitoring specifically to watch for drift. And maybe most importantly, you have to train the humans using the system to expect things to be variable and to know how to handle it. Okay, before we wrap this up, I want to be crystal clear about what this explanation is meant to do, and, just as importantly, what it is not meant to do. What we've done here is explain variance and drift as fundamental properties of AI, hopefully to get you and your teams ready to design for change. This is all about building the right mental model for safety and governance. What this is not is a how-to guide for tuning a specific model. It's definitely not an authorization to deploy a system into production. And it absolutely does not mean that this built-in variability is a failure. It's a property, and it just has to be managed correctly. So if you take one thing away from all of this, let it be this. AI systems are going to change. It's in their nature. Understanding variance and drift isn't just a nice to have, it is essential for building safe and reliable systems. And that means designing for change isn't some extra optimization you do at the end. It is a core requirement from day one.